Okay, let's move to next problem. This problem is about the pulley system. Okay, we know that point P on the cable has a velocity of 6 meters per second, which is increasing at rate of 3 meters per second square. We have the acceleration of point P now. Have this point. Okay, and at this point we have the acceleration. We know acceleration according to the model, and we know the velocity of point P. Okay, we would like to determine the power input of motor at the instant if it is operate with an efficiency of 0.8. If the efficiency is 1, this is the ideal machine that is no energy loss. So then in the power input is equivalent with the power output that is not never happen. Okay, so the coefficient is efficiency is about 0.8 is a good one for the machine. Okay, but actually it's the loss from the machine is maybe case that is maybe heat and sound or some deformation. This is always lost. So then if the efficiency is equal to 1, this is the ideal machine. So the mass of block A is equal to 50 kilograms for this case. Let's we consider the kinematics first. Okay, so for the system, we found that the position that is has no motion should be here. Okay, so then it's better to set up the datum line, the reference line at this line. Okay, because it has no motion. So when we would like to measure the point from the reference line or the datum, for point P from the datum is measured downward to point P, and also for point A is measured downward also. So then for this case, downward is positive. Okay, so according to this, the constraint length is the pink line. Okay, you see that the pink line is the combined together, it's become the constraint length. That is, we can form the constraint equation, come to SA plus SP equal to L. Okay, L is the constant, and now SA and SP is downward, is a positive. After we take the first derivative, we obtain this equation that is 2VA plus 3P equal to 0. And we found out VA equal to minus VP over 2. The negative signs mean that if VA is go down, okay, P is go up. Okay. In the same manner, if VP is goes up, if VP is go down, okay, VA go up. Okay, it's opposite. Okay, you may you may see from this picture, and it makes sense, right? When P is trying to move up, okay, so then A should be, when P is trying to move down, A should be moved up. Okay, and in the same manner, if P is moved up, okay, A should be moving down, something like that. Okay, in the same manner for acceleration, we have AA is equal to minus AP over 2. Okay, so negative sign is mean that it's opposite to the positive sign function that we set up. Okay, and now we the problem gives us that P is moving down. AP is equal to 3 meters per second square is moving down. Okay, from the problem is given that like this. Okay, so then it means that AA is equal to minus 3 over 2, that is minus 1.5 meter per second square, and it should be moved up because P is moving down. Okay, so after that, we consider the equation of motion for block A. Okay, actually, these two pictures, we may write the free body diagram just maybe like this. See, that is okay. It's not necessary to simulate like that. Okay, you may consider the whole system for block A like this. Okay, and you get the same is mg. Okay, and now because the form kinematics we know that goes down is positive 1. Okay, so from this free body diagram, okay, from this free body diagram, we can form the equation of motion. Okay, and the equation of motion for the block A, according to the free body diagram above. Okay, if you consider the free body diagram above, it's not necessary to consider this step. Okay, I write this free body diagram in order to show you that the assumptions of the neglect of the pulling mass. Okay, what happened to that for this case because we neglect the pulling mass. So then T2 is become 2T1. Okay, if the pulling mass is not neglect, we have to separate the free body diagram like this. Okay, in order to take care of the weight of pulling mass also. Okay, and if it is not, okay, we may combine the pulling into the mass of the block A also. So for this case, if we consider the equation of motion both, we found out when we give downward as a positive. Okay, so then mg minus 2t1 equal to ma. Okay, we know the mass already, and gravity constant is equal to 9.81, and we would like to find the tension in the cable T1. And we know the acceleration. Acceleration now is negative because we set up downward as the positive, right? But the from kinematics, we found out is minus 3/2, and it means that it goes up. Okay, but when we set up downward as positive, same as the kinematic that we define. So then we substitute it directly with the sign convention, and after that we solve this equation. We obtain the tension is become 282.75 Newton. And after that, we would like to find the power output now. That is the power that for making to the cable. That is that we already find the force and the velocity at this moment is equal to 6. Okay, it's equal to 6 meters per second. It's given from the problem. Now we have the power output is equal to 1,696.5 watt. Okay, to find the power input to the motor, okay, we have to use the efficiency of the motor that is equal to 0.8. So the coefficient, the efficiency is equal to power output divided by power input. Okay, so we know the efficiency. We know the efficiency now. We would like to find the power input. Okay, so then power input is equal to power output divided by the efficiency. So then the power input supplied to the motor actually normally it's maybe the electric power for that supply to the motor. It should be 2,120 watt. Okay, let's complete this problem.